Hello dear students, in this video we will discuss why 2,3-bisphosphoglycerate has more affinity for the hemoglobin A, that is adult hemoglobin, than the fetal hemoglobin. Or in the other way, we will also discuss why fetal hemoglobin has more oxygen affinity than adult hemoglobin. Okay, so stay tuned and watch this video till the end. So we will discuss why 2,3-bisphosphoglycerate has more affinity for the adult hemoglobin, that is HbA, than HbF. So for this we have to understand the structure of the hemoglobin A. So hemoglobin A structure, it has a 2 alpha chain and 2 beta chain. Okay, so hemoglobin, as we know, it is made of heme and globin. So in globin chains there is 2 alpha chain and 2 beta chain. Okay, if we draw the structure of hemoglobin, so there are 4 heme molecule. Okay, these are 4 heme molecule. Okay, and there is 1 alpha chain, 1 beta chain. Okay, that is the alpha beta dimer is there. Again another alpha chain and beta 2 chain. Okay, and with this each heme molecule oxygen is attached. So this is the structure of HbA. Okay, and whenever this 2,3-bisphosphoglycerate, what is this 2,3-bisphosphoglycerate? That is a negatively charged molecule because it has a phosphate group. This negatively charged molecule is present in the RBC in the same concentration like hemoglobin inside the RBC. Okay, so what is the role of this 2,3-bisphosphoglycerate? You know, it is an intermediate of glycolytic pathway in the Rapaport-Lubrin cycle. So what is the importance of 2,3-bisphosphoglycerate? Okay, like in condition of hypoxia or high altitude, the 2,3-bisphosphoglycerate level is increased. So what is the role of this 2,3-bisphosphoglycerate? So this 2,3-bisphosphoglycerate, okay, because it is a negatively charged molecule, it will bind with the beta chain, in the beta chain, where in the beta globin chain it is a protein chain. Okay, it is a protein. Globin is made up of amino acid. So in the beta chain there is a histidine molecule, especially at the 143 position of the beta chain there is a histidine amino acid. Okay, to this histidine molecule, that is a positively charged amino acid, 2,3-bisphosphoglycerate binds. Okay, so this 2,3-bisphosphoglycerate has strong affinity for the HbA or adult hemoglobin, and whenever it bind with the adult hemoglobin, 2,3-bisphosphoglycerate bind with the adult hemoglobin, so it will displace the oxygen from the hemoglobin. Okay, so in case of hypoxia or in case of high altitude, there is less oxygen in the environment. In that condition, 2,3-bisphosphoglycerate, it will displace the oxygen from hemoglobin so that it will provide oxygen to the peripheral tissue. Now this fetal hemoglobin has less affinity for the 2,3-bisphosphoglycerate. Why? Because in HbF there is 2 alpha but not 2 beta. It is a 2 gamma chain. Now instead of beta there is a gamma chain. So this gamma chain has a serine molecule instead of histidine. In fetal hemoglobin, the oxygen affinity for the hemoglobin is increased because this, what is the role of 2,3-bisphosphoglycerate? It will displace the oxygen. Okay, whenever it bind with the hemoglobin, it will displace the oxygen. But in fetal hemoglobin, because there is a serine molecule instead of the histidine, so the interaction between 2,3-bisphosphoglycerate and hemoglobin is less. So the oxygen affinity is more for the fetal hemoglobin. Okay, so we have discussed both the reason. 2,3-bisphosphoglycerate has more affinity for the hemoglobin A because there is a beta chain, there is a histidine molecule which will bind with the 2,3-bisphosphoglycerate. Okay, and it will displace the oxygen. Okay, so that oxygen is available to the tissue. While in case of fetal hemoglobin, it has a serine molecule, so this 2,3-bisphosphoglycerate has not that much affinity for the hemoglobin than the HbA. Okay, while this HbF has a more oxygen affinity. this HbF has more oxygen affinity, because as we have known that 2,3-bisphosphoglycerate cannot bind with the hemoglobin, fetal hemoglobin. So the oxygen affinity is more for the fetal hemoglobin than the HbA. So this 2,3-bisphosphoglycerate and oxygen affinity, they are inversely related to each other. And what is the advantage of HbF has a more oxygen affinity? So in the fetus, in the embryo, the lung is not developed, but it requires the oxygen. Okay, so the fetus hemoglobin or embryo has a HbF. Okay, while in mother there is a HbA. Okay, so because HbF has a more oxygen affinity, so it will take up the oxygen from placenta. Okay, from mother oxygen, the fetus take up the oxygen. That's why HbF has a more oxygen affinity. See the beauty of God, see the beauty of nature, how there is a switching of the hemoglobin. Okay, so after the baby is born, so then HbF is swapped to the HbA. We understand this topic in the another diagram, like there is a hemoglobin alpha 1 chain. Okay, this is a beta 1 chain of the hemoglobin. Okay, there is a, this is a beta 2. Okay, and this is a alpha 2. So this is a structure of, because 2 alpha chain and 2 beta chain, this is a HbA. Here in the, there is a pouch is generated. Okay, and in this pouch, these beta chains are interacted with the loose ionic bond. Okay, and here this 2,3-bisphosphoglycerate will bind to the positively charged amino acid called histidine. Okay, so 2,3-bisphosphoglycerate bind with the adult hemoglobin, so it has a more affinity, and when this 2,3-bisphosphoglycerate will bind with the hemoglobin, it will displace the oxygen. So oxygen is available to the tissue. Okay, while if there is a gamma chain instead of beta chain, there is a gamma chain, what will happen? There is a serine amino acid will be there here instead of histidine. So 2,3-bisphosphoglycerate cannot bind to that, so the oxygen affinity is more for the fetal hemoglobin than hemoglobin A. Okay, and so that it can take up the oxygen from mother. Right, I hope you understand the concept. I hope you like this video. If you like this video, please hit the like button, share this video to your friends, and subscribe to my channel, that is Live Biochemistry, so that you can get notification for my future video also. You can visit my website www.livebiochemistry.com, where you will find the study material regarding the biochemistry.